Good evening, ladies and gentlemen. Welcome to this virtual VPS Roundtable seminar on fuel management challenges moving forward. We are doing this VPS seminar in conjunction with the very first virtual SIBCON, which is being held in Singapore. It is a pleasure to see many familiar names, unfortunately no faces this time, and many new participants as well. So thank you all for joining us online today. I'm sure many of you have already attended this very well organized and informative virtual SIBCON, where significant topics surrounding marine fuels have been discussed, both for today and the future. So even though many of us have been to some of these seminars already, there is still, I believe, more to learn. And even if we can take back some key tips to apply to your work today, this roundtable will have been worth it. We have a healthy participation list, which is growing as I speak. So that's a positive sign indeed. Do note that our focus today is on fuel management challenges with VLSFOs and oil condition monitoring trends and implications. Bunkering of ships covers a very large number of topics, but we would like to keep the focus today on these fuel-specific management matters. Secondly, the intention to have a roundtable discussion today with knowledgeable individuals in the participation is to facilitate a cross-thinking of ideas, because we are not dealing with a simple issue here. There are complex aspects to consider, so you can act upon them wisely. As mentioned, we will do the Q&A session after both the presentations are completed today. So please write your questions in the Q&A button, as also mentioned, as the presentations progress. Please put in your name and company as well, so we know who you are. Lastly, I think this roundtable is different because although we are managing this as a VPS roundtable in-house, we are in fact intentionally gone for a very, very wide industry participation today. We have ship owners, ship managers, fuel suppliers, bunker tanker operators, lubricant manufacturers, additive manufacturers, industry associations, port authorities, P&I clubs, etc. All of us, I believe, plays an important role, and it is in this dynamic context of working together that we are having this seminar. Then, without further ado, let me introduce our first speaker, Steve B. Steve is our Group Commercial and Business Development Director for Veritas Petroleum Services, responsible for the development and implementation of VPS Global Commercial Strategy since joining the company in July 2016. He graduated from Northumbria University with a BSc Honors in Applied Chemistry. Steve worked as an R&D chemist for BNFL, ICI, and Sanofi Aventis before joining Anachem in a commercial role within laboratory implementation in 1997. Progressing his international commercial career, Steve moved into technical sales, from technical sales to sales and marketing manager, before becoming the general manager for AI Envirotech, gaining formal business management qualification and awards along the way. Steve joined Lintech Testing Services, a subsidiary of Intertek, as operations and key account manager in 2007, before becoming general manager of Lintech in 2011, and then director of Intertek Ship Care in June 2012, a role he held until he joined us in VPS. Let me also take this opportunity and introduce Paul Parkinson, who will be speaking after Steve. Paul is the Group Oil Condition Monitoring Business Development Leader for Veritas Petroleum Services. He's an experienced manager in the testing, inspection, and certification sector and has over 30 years of international B2B technical sales and operational management experience. After studying applied chemistry at Liverpool John Moores University, Paul worked as a laboratory manager for an environmental consultancy at the Liverpool University. He then joined SGS UK, where he performed a range of laboratory management roles. During this time, Paul also gained formal business management qualifications. Progressing his international business career, Paul moved to Vernolab, a French OCM company, in 2002 and became their managing director in 2004. After its acquisition by SGS, along with his MD role, Paul became the analytical services manager and was responsible for an additional 2 laboratories, including the Stanlow SR Refinery Laboratory. Paul joined VPS on the 10th of April 2017 and is responsible for the development and implementation of the VPS oil condition monitoring operational and commercial strategy. With that, we are ready to start our roundtable seminar. Ladies and gentlemen, and let me pass the baton to you, Steve.
Many thanks, Rahul. Good day, everyone. Many thanks for taking time to join this VPS roundtable event. It's fair to say, I think that 2020 has been a unique year in regard to the challenges it has raised to the shipping industry. With not only the IMO 2020, but then these regulatory requirements being quickly followed by the global impact of the COVID-19 pandemic. However, today I'd like to share with you VPS findings over the course of 2020 regarding our testing of the new VLSFO fuels and the conclusions and advice we can offer through our experience and innovations to support your business operations in a sustainable manner. In terms of VLSFO supply and demand, the 1st of January 2020 saw an immediate switch to VLSFOs, and this far outweighed the anticipated increase in demand for MGO. The latest figure shows 65% of samples received by VPS are now VLSFOs. We haven't seen an increase in MGO demand, which currently equates to about 12% of all VPS samples received. However, since the end of February, we've seen a month-on-month increase in HSFO demand, resulting in a 43% growth. And currently, HSFO samples equate to 21% of all VPS samples. We believe this increase in HSFO demand can only be really attributed to an increase in scrubber usage month-on-month since the end of February. Overall, there is wide availability of VLSFOs across the globe, with Singapore being the port supplying the most VLSFO volumes. Whilst the year started strongly in terms of VLSFO volumes, the COVID-19 pandemic certainly caused a negative impact on bunkering between March and June. But thankfully, we're starting to see the signs of recovery since July into August, and now thankfully into September too. In terms of sulfur compliance, VLSFOs have varied month on month throughout 2020. We saw a monthly decrease in the number of sulfur off specs from December 2019, where it was around about 6%, down to April 2020, where it was only 1% off spec sulfur. But then, since then, we've seen successive increases in May, June, and in August. Currently, we're seeing around about 3.7% of all samples tested exceed the 0.50% sulfur. Of these off specs, 0.8% are actually exceeding the 95% confidence limit of 0.53% sulfur. In terms of flashpoint, 17 out of 37 bunker alerts issued by VPS this year have been for low flashpoint within fuels. and all fuel types have actually been affected to some degree. MGO has required 9 flashpoint bunker alerts, followed by VLSFOs with 5, and then HSFO with 3 bunker alerts. I think due to the COVID-19 pandemic, both road and aviation fuel demand has decreased significantly, leaving a surplus of these fuels at a relatively low cost. Therefore, we believe in certain cases these fuels have been blended into marine fuels, and being a more volatile material than marine fuels, this blending has had the impact of lowering the flash point of the marine fuels that we've dealt with. In terms of viscosities, VLSFO viscosities have been wide-ranging since VLSFOs were first introduced to the market. And we're currently seeing a range of about 5 centistokes to just over 400 centistokes as the viscosity range. But 77% of these VLSFOs are actually less than 180 centistoke viscosity. It's very rare these days to see a 380 centistoke VLSFO, and currently only 4.7% of fuels tested have a viscosity which is greater than 280 centistokes. Viscosities have lowered over the year, probably due to lower or lighter materials being blended into the fuels. If we look at densities, these have also varied greatly in their range since coming to the market, and we're currently seeing around about a range of 853 kilograms per meter cubed to just over 1,000 kilograms per meter cubed. And again, 60% of the samples tested lie between a range of 920 to 950 kilograms per meter cubed density, with only 2.8% being greater than 981 kilograms per meter cubed, still obviously below the 991 limit that we used to see for the HFO materials. In terms of cat fines, initially there was a concern and obviously proof that these were initially high in terms of what we'd seen previously. But these have improved significantly over the course of 2020. In January, 22% of the VLSFOs tested had a cat fine level which was greater than 40 ppm. However, as the years progressed, this has finally dropped down in August to a level of about 9% of the cat fines having a level of greater than 40 ppm. The current range that we're seeing is probably from about 2 ppm to a maximum spike in August of just over 300 ppm. However, overall, the global cat fine average is currently 14.9 ppm. We believe the improvement has been due to lower levels of residual components in VLSFO blends as the year has progressed. If we move on to stability, VLSFO stability has certainly been the most concerning issue this year. In all bunkering regions, the average TSP has been on specification, yet we've seen many stability issues where within weeks of delivery, the fuel has become unstable. And we believe that the VLSFO currently have a shelf life of less than 3 months in comparison to HSFO, which has a shelf life of around 6 months, and MGO, which can be anywhere up to a year. In addition, we've seen cold flow properties as being a key concern operationally as well. Currently, 99% of the VLSFOs tested have a pour point which is less than 30 degrees centigrade. Yet their wax appearance temperature, or cloud point, is currently on average about 24 degrees higher than the pour point. So this really can render the old advice of storing fuel at 10 degrees above pour point as irrelevant in many cases, as wax may have already begun precipitating at a higher temperature than 10 degrees above pour point. Currently, 78% of VLSFO's wax appearance temperatures are greater than 30 degrees centigrade. In addition, the wax disappearance temperature, i.e. the temperature which is required to make any precipitated wax go back into solution, is currently 10 degrees higher than the wax appearance temperature. And 77% of VLSFO's wax disappearance temperature is greater than 40 degrees centigrade. So overall, VLSFO storage temperatures are key in avoiding operational problems. A VPS technical paper covering our proprietary wax appearance temperature test method was actually published back in October of last year, and it is available on request. I'm now going to consider some cold flow scenarios. First of all, VLSFOs with a high TSP and high watt. Heating these fuels in the storage tank whilst keeping the temperature above the wax appearance temperature in order to prevent cold flow issues can potentially cause TSP to rise and decrease fuel stability. By the time the vessel starts to burn the fuel, the TSP could have become off spec and form a thick sludge. Typically, the fuel forms sludge at the purifiers, and increasing the temperature further, i.e. from the storage to the separation temperature, has generally worsened the situation. Therefore, the recommendation would be to limit VLSFO bunker storage time on board to about 2 months. Next scenario is VLSFOs with low viscosity and high wax appearance temperature. The fuel's separation temperatures may be lower than the wax appearance temperature, and for that reason, the vessels cannot at any time really heat the fuel above the wax appearance temperature. This causes a problem with sludge formation in storage tanks and transfer pipelines, and can result in filter clogging with wax, and then together with this is a serious handling and transfer issue. Therefore, the recommendation would be, my apologies there, recommendation would be to use additives in a controlled manner. In certain cases, these can improve the situation enough to actually burn the remaining fuel. And then finally, where VLSFOs have a wax disappearance temperature greater than 75 degrees centigrade. Here we suggest that carrying out the exact flash point test in order to make sure that the fuel is not being heated above the flash point. In terms of op specs, VLSFO op specs relevant to the ISO 8217 spec limits show that currently 7% of VLSFOs exceed at least one test parameter specification, with sulfur probably accounting for almost half of the VLSFO op specs. In terms of region, Europe currently has the highest level of op spec VLSFOs. That's at 17% of VLSFOs exceeding this test, at least one test parameter specification. And here, the off spec parameter is mainly sulfur. By comparison, Singapore currently has a VLSFO off spec rate of 4.2%. But in this case, the parameter of concern is mainly flash point. During the first quarter of this year, VPS witnessed over 40 vessels suffering with broken piston rings, damaged cylinder liners, and hard deposits on piston crowns. This warranted a full investigation by VPS, and we published our findings and conclusions in a technical white paper in May of this year. Of the 40 cases, all the vessels burned on-spec VLSFOs, and all used a base number 40 lubricating oil. We found that two-stroke engines were most susceptible to this issue. And yet there were numerous fuel and lubricant suppliers, various engine manufacturers involved, so no one specific repetitive cause or reason in terms of the supplier or the engine manufacturer. The actual cause was high reserve base number of cylinder lube oil, not being fully utilized to neutralize the acidic component of the fuel during combustion due to the lower sulfur levels within the fuel. This resulted in hard calcium deposits appearing on the piston crown, causing liner wear, scuffing, and broken piston rings. And it's worth noting that when base number is reduced, the detergency effect of the lube oil reduces and the oil film is lost. However, when the base number increases, the detergency improves and the oil film is retained. However, calcium deposit formation can begin, but the acidic presence from the fuel is reduced due to a sulfur reduction. The white paper that we produced on this investigation, again, is available upon request from VPS. I'm going to move on now to BQS of VLSFOs and highlight that in January of this year, we recognized that some bunker quantity surveys relating to VLSFO delivery encountered large quantity shortages in excess of about 140 metric tons. The contributing factors to the issue varied, and some of the observations that we saw during the survey being that VLSFO bunkers were not stabilizing in the sounding pipes, and this led to inaccurate measurements. Also, prevailing low ambient temperatures causing waxy conditions of the VLSFO and poor flow of the fuel. In such cases, obviously the vessel's chief engineer would normally issue a note of protest to the supplier's representative for the alleged quantity difference. However, it's also worth noting that the importance of engaging a bunker surveyor service in order for the parties concerned to really assess and understand the following. So this would be the precautions that would be needed during the bunker survey to detect these losses and where these losses may have occurred, an independent assessment of the situation and giving notification of the issues on site in real time, identifying the final quantity difference encountered and also the possible reasons for these quantity differences, documenting of obviously the action that will be needed to be taken, and if possible, if allowed, providing photographic evidence in support of the findings, and also to ensure that we are able to then follow up at the next port and finally give an assessment of the completed investigation and the provision of a conclusion as to why this quantity difference occurred. The closure of the issue by the surveyor will certainly benefit the buyer, the chief engineer, and also the seller. In addition, following the correct procedure to obtain the representative sample is crucial, especially for VLSFOs, where obviously the sulfur content is now being closely watched by port state control. Improper sampling leads to inaccurate test results and information. This will in turn lead to obviously a potential dispute situation where more samples will be needed to be tested. An unwarranted situation would be that samples drawn from the vessel's nominated tanks give a completely different result in comparison with the initial test done on the bunker samples retained on board. And finally, in terms of bunker quantity, VLSFOs will certainly be affected by the flow properties. In this context, knowing the wax appearance temperature and the wax disappearance temperature will be crucial for both the buyer and the seller in order to avoid a no flow or large quantity loss during VLSFO bunkering. So in summary, VLSFOs are currently the most popular bunker fuel of choice, and they account for 65% of all the samples received by VPS. These fuels are definitely widely available around the world. And we have witnessed, in terms of marine fuels, since the end of February, a 43% increase in demand for HSFO, indicating obviously an increased usage of scrubbers. Yet the anticipated demand for MGO hasn't materialized, well, certainly not as yet. VLSFO sulfur global compliance has varied month on month from 6% down to 1% off specs. And currently the off spec sulfurs run at a rate of about 3.7% for all of the VLSFOs tested, and that's exceeding the 0.50% sulfur limit. COVID-19 impact and the low demand for road and aviation fuels has seen these fuels potentially blended into many marine fuels, resulting in a number of flashpoint issues. VLSFO densities and viscosities continue to be variable in their ranges, but as the years progressed at a lower level. Certainly lower than the 991, the density and the 380 centistoke viscosities we previously see with HFO fuels. VLSFO stability and cold flow issues are probably the most common concern for vessel operations, where on-spec VLSFOs can be quickly destabilized on board a ship within weeks of delivery. So the storage and transfer temperatures require very close monitoring, and that's in terms of their pour point, wax appearance temperature, wax disappearance temperature, TSP, and viscosity. Overall, current data shows that 7% of VLSFOs tested exceed at least one test parameter specification. VLSFOs and lubricating oil together both require close monitoring in order to avoid engine damage such as we've seen with the cylinder liners. So there's been numerous factors, I think, during 2020, which have resulted in the need for an increased focus on the fuel management of VLSFOs. So I hope you've found the VLSFO findings of interest. Obviously, after Paul's presentation, I'll be happy to take and answer questions on the VLSFO testing that we've done to date. And with that, I shall hand you over back to Raoul, who I'm sure will introduce Paul to give you a talk on the OCM findings of VPS. Thank you very much.
Thank you, Steve. Thanks for that. Packed a lot of information. We've got a number of questions, but we will hold on to that. Floor is all yours, Paul. In this case, unfortunately, a Zoom floor, but all yours.
Okay, thanks, Raoul. Just bear with me while I activate. So thanks, Steve. Welcome to you all, and a big thank you for such a fantastic attendance to our presentations. Although I'd like to think this is a reflection of Steve and I, and VPS as a whole, I suspect this turnout also shows the significant impact that IMO 2020 has had on the marine industry in both a fuel and lubricant sense. Hopefully, so you've heard what Raoul has explained about my background, and in short, I'm a chemist and a businessman, which is a bit of an unusual combination in this world, but it's very useful in terms of oil condition monitoring. So for the agenda today, we've got quite a bit to get through, and I think we're running behind a little bit as well. So we've got a short time, so please, as has been said, use the question and answer session at the end. And if anything else comes out of this, we've obviously got the local VPS account managers and myself for further discussions. But today, I just want to talk about oil, and specifically oil condition monitoring. What I presented last year, because we did a similar sessions around the world last year, what's happened this year, what are the issues, and Steve has touched on a few of them already, and we will then talk about how we can resolve them, what the solutions are, and we'll finish up with a question and answer session. Okay, so on lubricants and additives, there are two main categories of lubricant oil. There's the mineral and there's the synthetic kind. The mineral oil is derived from crude oil following fractional distillation. You can see a diagram there. The main functions of the lubricants are to reduce friction and any wear while cooling, absorbing, and cleaning. Now, to help with that process, oil additives are chemical compounds that improve the lubricant performance of the base oil or the base stock. These additives can comprise up to 25% by weight of some of the oils, and the choice of the additives is determined by the specific application. Today, I want to focus on alkalinity additives, particularly calcium carbonate, and what they do in terms of neutralizing the acidity of the oils. Oil condition monitoring is a predictive tool that uses laboratory analysis coupled with an understanding of lubricants and engineering. The degradation of the lubricating oil occurs naturally over time as these protective additives are consumed and break down products. Sorry, I've just got a message to say we can't see the slides.
Yeah, sorry about that, ladies and gentlemen. That's correct, Paul. So you may need to backtrack a little bit.
Okay. Let me just check in with you then, first of all, Raoul.
Yes, that is correct. Yes, very much on now.
So can you see the slide that says OCM is a predictive maintenance tool?
Yes, yes, I can. Go ahead, Paul.
All right. Okay, so carry on. So yeah, OCM is a predictive tool that uses laboratory analysis coupled with an understanding of lubricants and engineering. The degradation of the lubricating oil occurs naturally over time as the protective additives that I spoke about are consumed and break down products buildup. By testing the oil and diagnosing the results and trending this data over time, valuable information on the condition of the equipment can be obtained. Oil condition monitoring therefore provides an early warning system that helps avoid costly equipment failure and downtime, and therefore has an important role in preventative maintenance programs. The science is known as tribology. The best analogy to explain this is the blood test, and this is taken by your doctor to identify, predict, and help combat any potential health issues. Now, this chart is an important chart. And I'll refer to this a few times through the talk, but this shows the cost and the risk effects on the condition of an asset, whatever that asset may be over time. Inevitably, cost and risk will increase once there are signs of deterioration to the point where there is complete failure. Are we still okay with the slides, Raul?
Yes, Paul.
Okay, thank
Great.
you. All right. So here you'll see some images of our VPS OCM laboratory, specialized equipment that is used to test for oil condition monitoring. Now, as you can see by those images, OCM doesn't rely on just one laboratory test in order to establish appropriate advice. It utilizes a combination of parameters. And this table explains a range of tests and the basic relevance of each of these tests. So for example, the color of the oil can indicate a level of oxidation, and a positive flash can indicate the presence of fuel in the system. The highlighted parameters that I've shown in the table are those that are particularly important with the situation we're talking about with cylinder oils. Now, Steve and I presented to almost 1,000 people through 10 IMO 2020 seminars and roundtable meetings in 8 countries last year. And you might remember some of these slides if you attended one of these talks. And this is where my particular perspective as a chemist and a businessman comes into place. This diagram describes strategic drift. And the photographs are of Henry Mintzberg and John Cotter. And these two are giants in the business world of change management. And they both say that we must manage change and continuity simultaneously. And the challenge, therefore, is to balance the two. And for IMO 2020, we're aiming to get to phase 4 on the chart. And I proposed back in 2019 to apply this business thinking to the change with sulfur requirements. So we're trying to get to phase 4, and there are, I'm aware, various options available. And each of them have their own merits, whether it be availability, effectiveness, or price. But whatever your solution was, it will have an effect on the lubricant. And this is where OCM is effective. As mentioned, lubricant can be an aid to help identify potential problems and areas to improve and help formulate a solution. OCM can be the mechanism to help with this challenge of change. Back then, I focused on cylinder oils and the role of base number additives to combat acidity. And financially, in a procurement sense, this is very important. ExxonMobil, for example, say that cylinder oil equates to 65% of the lubricating budget on board ship. Our base number is a test to show the oil's ability to neutralize acids that are formed. And typically, the higher the base number, the more acid it will be able to neutralize. During the combustion cycle, sulfur in the fuel is released, forming sulfur dioxide. And some of this goes on to form sulfur trioxide. And water that's contained within the scavenging air and from the combustion process reacts and it forms sulfuric acid. As oil is used in service, it becomes contaminated with these acids and causes the base number to drop over time. And the rate of the drop is determined by the amount of acids introduced to the system. So as I've said, by using oil analysis, you'll be able to track the base number of your oil and determine how much life is remaining. So last year I proposed 2 possible scenarios. As we'll know, most 2-stroke engines are designed for operation on high sulfur fuel. So this scenario fits for the users of scrubber technology. Consequently, the cylinder oil used will have a high base number, typically 100 BN. And if the acid is not neutralized, corrosion of iron will occur, and this is the primary cause of corrosive wear for liners and piston rings. A vessel that uses VLSFO will produce less sulfuric acid during the combustion process, and so therefore a lower BN is required. But if the BN is too high, this may mean that the oil is too alkaline, and then compounds can be formed which may cause damage. You can also refer to the comments from CIMAC, who are the International Council on Combustion Engines, their user guide 30 on base number, and also the CIMAC guideline 11 on cold corrosion in marine 2-stroke engines. So if you mix all this up, what we talked about last year, the industry was greatly uncertain and very apprehensive about the future. And fueling this uncertainty was cost and risk. Now, if you remember that chart earlier that I showed in an earlier slide. And last year I also spoke about the Swedish club, which you'll probably know about the Swedish club already. They have a very important part to play in the industry as an independent insurer and a provider of insightful information. So you can see by their 2018 main engine damage report that the cost of a cylinder damage alone is over $500,000 US. Now, I wonder whether those numbers of claims and the average cost has changed during this year. So this, coupled with the cost of cylinder oil that I mentioned earlier on a vessel, tells us that this is a financial problem that we need to solve. So, how close were we with the predictions of last year and those harbingers of doom? So let's look at the position in 2019 before the change. And what this chart shows is the number of samples that were regarded as green, amber, and red that were tested by VPS OCM. And you can see that over 50% of all of our oil samples were fine, 34% had an amber warning, and 11% were considered critical. Now, where possible, VPS use OEM limits as our guide. So let's look at the percentage of those samples that were cylinder related. 13.2% of the ambers were cylinder related, and 14% of those red samples were cylinder related, and 6.1% overall of the reds and ambers were related to cylinder issues. So that was pre-IMO 2020. So let's look at the same exercise for 2020. And what you can see there, first of all, is a similar overview with in fact an overall improvement in the greens, a reduction of the ambers and the reds. These are all samples that were tested by VPS. So this is a good overall picture for the tribologists that are among you in the audience. However, the picture is very different in terms of cylinder related issues. And what you'll see there is that there were nearly 3 times more ambers and reds and twice overall of all cylinder connected issues. twice the number of ambers and reds of cylinder-related issues. So I'm sure that the Swedish Club report will reflect this for 2020. Steve has already spoken in his presentation about VPS being a technically orientated organization, and we actually attend panels on oil, fuel, and OEM, and we investigated this significant rise in detail, and we broadcasted a white paper to the industry explaining our findings. Now, if you didn't receive the white paper, I would ask you to please, again, contact your VPS account manager for more information so this can be provided. So here are some of the findings from that white paper through the lens of 2 key tests on cylinder oil scrape down analysis, which I'll talk a little bit about later. The 2 tests are iron content and base number. I'll just pause for a moment while you can look at that table. There's a lot of information on there, and it describes before the incident, during the incident, and after the incident. And what you can see is that before the incident, the iron content in all of the 5 cylinders appeared to be satisfactory. And so the cylinder scrape down oil appeared to be satisfactory and within limits. Now, when we start the incident, you see that the iron content in all of the 5 units appear to be elevated. And considering that the cylinder oil in use is a 40 BN and the fuel sulfur of approximately 0.4, the base number in the scrape down oil appears to be close to or marginally above the new oil value. And then if we move into after the incident, you'll see that there is a significant sharp spike in the iron content in unit number 5, followed by number 4 and unit number 3. And this is also backed up by one of these additional tests that I talked about before. There were high PQ index that were indicative of wear. High reserve base number on all units are observed, and given that it started at 58, and particularly a very high base number was observed on unit number 5, which incidentally also shows the highest level of iron content at 9,898 parts per million. Similarly, number 4 had 85, number 3 90, and number 2 81. One of the common features noted in this type of damage was the presence of deposits arising on the surface of pistons, and Steve mentioned this in his presentation as well. The deposit was concentrated on the piston head and in areas around the piston crown. They were hard in nature, and they were either white or grey or reddish coloured. And the samples of these deposits were also analysed for elemental composition. So you can see a breakdown there. And this table clearly shows that the piston deposits were mainly formed of calcium. Our white paper proposed that this originated from the reserve alkalinity in the cylinder oil, and there was a much smaller amount of vanadium that arose from the fuel oil. Further to that, you can see an increase in iron content, and this indicates abnormal wear of that cylinder unit and the piston rings. Alkaline deposits building up on the piston crown can damage the oil film between the piston ring and the liner, and this can lead to scuffing and seizures. Deposits that form between the piston rings and the pistons prevent free movement of piston rings and increase liner wear. So let's talk in a little bit more detail about scrape down analysis. This is a key element of our OCM service for cylinder performance and health. And what you can see here is an example of our detailed scrape down report. The box at the top allows you to quickly see the effect of combining iron and base number. The green box against the traffic light system, the green box indicates the area of safety and good practice. And it also shows the effect of a higher or a lower base number with respect to wear and the increase of iron. Each of the cylinders are plotted to assess their condition for each of these two parameters. And you can see some marks just to the right of the green box there, and they're each of the cylinders. Our reports also categorize oil condition monitoring aspects of every cylinder, and these are shown graphically, and they're also shown by commentary as well. So in this case, pretty much like the case study that I talked about before, there's a surplus of base number, which will probably cause deposits and damaging wear of the cylinder liner, as was shown on the previous slides. Now, Stephen, his presentation talked about fuel quality, and we've also discovered through conversations with our customers and the industry that scuffing might not just be due to this deposit formation. And Steve spoke about fuel quality issues in his presentation, and some of our customers have also highlighted combustion issues that are showing a delay in ignition. CIMAC have again provided plenty of information on this subject through their fuel quality guide on ignition and combustion. So, what do we do? I'm stating the obvious here, but we want you to select the correct base number cylinder oil. Now, if you're changing supplier, VPS can help you with this transition to make it as efficient as possible, and we can help you minimize costs through our in-house compatibility methods. We can investigate the effect of different ratio mixes and aging on properties of these mixtures. As I've mentioned in previous slides, regular scrape down analysis is a great tool to identify cylinder condition, but sometimes it might be too late for the vessels to react by the time they get the analysis results from the lab. Now, although it's not a substitute for sending samples to the laboratory, procuring an onboard kit for measuring iron and base number is useful. And as soon as any changes are done to the cylinder lubrication, the vessel should take a sample from each of these units and analyze it so that immediate action can be taken. Following which the same subsamples can be sent to the lab for a detailed scrape down analysis. The feed rate shouldn't be altered without considering a range of parameters, but mainly base number and ferrous content in the cylinder scrape down oil. The optimum feed rate can normally be identified by carrying out what's called a sweep test. The sweep test is useful when you're changing oil or fuel and you're running in a new engine, or you're renewing your liners, and you need to verify and readjust your feed rate if you need to. This will optimize the cylinder condition and the oil consumption. For the sweep test, a sample is taken from each cylinder from day 1 to day 6, and they should be labeled with all of the required information. And it's also recommended to refer to your engine maker's guidelines when you're conducting the sweep test. Before the sweep test, the cylinder condition and the wear must be thoroughly assessed through an initial inspection, and preferably this test should be performed with a calm sea and under stable engine operations. As well as the samples for the sweep test, we would require the fuel that's in use. We could be actually testing that sample already, that fuel already, so you could just give us the sample number. We need to have the system oil that's in use and any cylinder oil, unused cylinder oil, for comparison. As has been mentioned, the scuffing could be as a consequence of the fuel. So please again, use your analytical test partner to test for fuel for its ignition and combustion properties. Finally, I would just state the obvious again: closely monitor your engine operations, especially during any changeover, listening and looking for any knocking sounds, and notice and record any load unbalance or any unusually high exhaust temperature deviations. So final slide now, and I just conclude my presentation by highlighting the importance of the following aspects of our VPS OCM service for you to consider and for you to compare with maybe other suppliers that you have. We are completely independent of any manufacturing experience. Our role is to provide an impartial assessment of fuel and oil. I've made the point, hopefully through the presentation, of the relationship between fuel changes and oil, and so I suggest that you use a provider that can provide both services and allow a complete and holistic assessment of your vessel. VPS are recognized as the market leader and an innovator in the industry, and I think this is important, remembering back to the business chart about strategic drift before. It's particularly important in an industry that's changing. For us, examples of innovation are our abilities in change management, and particularly through our compatibility testing, and also our advanced robotics laboratory and IT reporting and delivery systems. And then finally, even with all of the sophisticated technology we have, it's very important the working relationship you have with your suppliers. And we can deliver this through our global network and our local account management structure. Thank you. Back to you, Raul.
Thank you, Paul. Appreciate it, and lots of information there for all of us. I'm going to dive straight into the questions. There are plenty of questions for both you and Steve. Just to let the participants know, we may not be able to answer all your questions, but we'll do our best as much as we can today. And if we can't, we will come back to you separately. So, Steve, I'm going to start with you and let Paul take a moment's breath. There is a question from Vikas Kumar, a close colleague and friend all the way from Hong Kong. And his question is, what is the reason for VLSFO causing high liner wear in the engine due to fuel, which has generally was within the limits of 8217? Is it late injection? What are the reasons? And could you give an indication, what could give indication of it during testing prior to the bunkers? And there's an added question from him, is it due to high calcium deposit on the crown due to high TBN, which has not been scraped off by piston cleaning ring? So Steve, will you take that? And if Paul wants to join in after you, he's free to do so.
Thanks, Vikas, for the question. I think it's to try and maybe simplify, by not getting into too much of the chemistry. It's basically an acid alkalinity neutralization issue. What we saw, obviously, as the sulfur levels within fuel have reduced, obviously sulfur lends itself to forming an acidic medium within the fuel. So the higher the sulfur, there's a tendency for obviously higher levels of acidity. And obviously the part of the job of lubricating oil, one aspect of lubricating oil's function is to provide obviously enough alkalinity to neutralize that acid so you don't get the acidic corrosion of metal surfaces, etc. However, if the sulfur has reduced within a fuel, obviously then the acidity or potential acidity reduces. And if the alkalinity of the lube oil is effectively still at a relatively high level, then you will actually have a higher alkaline environment. And high alkalinity can be just as corrosive as high acidity. So you've got this issue of higher corrosive potential from the high alkalinity. Obviously, calcium is the big part of obviously this this alkaline portion, and you can get alkaline then calcium actually in an alkaline form depositing on piston crowns. So these calcium deposits then become very hard and abrasive, and again that will effectively lead to the effects that we've seen in terms of cylinder liner corrosion. Anything to add on
Thank
that,
you,
Paul?
Steve. Thank you, Steve. I'm going to.
Yeah,
Paul,
sorry,
you want to add?
sorry, Ral, I'll just add a little bit more to it. Steve is totally right with that, and it's this imbalance that's caused. So the additives there are there to combat any acidity in this case, but if there's an excess of the additive, the imbalance, it becomes an imbalance then. So the equilibrium then creates deposits that any deposits in an environment like in the piston area become problematic then, and they break down the film, the oil film that was described, and they can be quite damaging. So it's important that you get the equilibrium right, and the only way you can do that is by testing the samples.
Okay, Paul, I'm going to keep you there. There's some additional questions. There's one question from Mr. Sanat Mohapatra from JESCO in Mumbai. His question is a regular SDA analysis means how often you recommend. Do you recommend onboard testing kits as sometimes lending samples to lab is difficult? You want to take that, Paul?
Yep, yeah, it's a good question, very good question. And I'm often, so remembering now, today we're talking about cylinder analysis, but oil condition monitoring refers to everything that has lubricant or grease to protect the equipment. So anything on board the ship that is considered to be critical. Now, in this case with cylinders, so I would say generally that people would test every 3 months on board the vessel. But obviously, if you're going through some change or you're concerned in some way, I would reduce the frequency. So you could almost become, you could test on a monthly basis if that gives you comfort. And then once you're satisfied through our analysis, we could widen it out to 3 months again. So it's really about your attitude towards risk. But generally, people test every 3 months. So that's the first part, I would say. And then the second part about onboard test kits. I made the point in the presentation. They have a place in laboratory testing. I would not, because of our independence, I would not recommend a particular one. That's for you to decide. There are plenty on the market for you to gain some satisfaction from. But they cannot duplicate what happens in the laboratory. You know, the laboratory that we have in Rotterdam it costs $1 million, and there's no way a small box can replicate a laboratory of that size. So it's a screen test. It's something that just gives you an indication of what's happening, and then you should follow that up with testing from a static laboratory.
Thank you, Paul, for that. Steve, I'm going to go back to you. There's a question, there's actually a couple of questions on TSP, and this is from Mr. Anjan Sahu, who is from JESCO and all the way from Mumbai. And his question, though TSP is the indicator for stability, why is it that RSN, or separately number, also an indicator of stability, is in variance with TSP? Stability is a big issue with VLSFO. And there is a linked question from his colleague, Sanat Mohapatra, that TSP becomes high due to storage, longer storage bunker tanks. How do you go about using the fuel, and what are recommended test precautions before usage? You want to take that, Steve?
Yeah, I can take that. First of all, the TSP RSN question. TSP basically gives obviously the indication of the potential for obviously sediment to fall out of the fuel solution. So in essence, it's telling you in effect how much potential sediment is there. RSN, reserve stability number testing, acts almost like a complementary test to that, in the way that it actually will try and predict what the likelihood is of that sediment potential falling out of solution. Okay, so you may have a fuel that has a very low sediment, but it has a high RSN number. So even though there's a low amount of sediment there, because the RSN isn't particularly strong, that sediment will actually drop out of solution. It may not be much, but it will drop out of solution. The converse, again, you could have obviously a high amount of sediment, but the reserve stability of the fuel is very strong. So even though there's a lot of sediment there, because of the strength of the reserve stability, you can actually hold on to that amount of sediment and retain it. Obviously, the worst case scenario is that you have basically a poor reserve and you have obviously high sediment, and then obviously the chances are that it will drop out. So the two tests actually work in complement. One is how much is there. The other is basically what is the likelihood of being able to retain or not retain the sediment within the solution. In terms of the storage, yes, I did have a slide on this. Obviously, what needs to be sort of considered here is certainly the cold flow properties of the fuel, as well as the TSP and the viscosity. So you may have a fuel that has obviously a high wax appearance temperature. So you're therefore storing that fuel hopefully above the wax appearance temperature to avoid that wax precipitating out. However, the higher the temperature that you're storing that fuel at, and the longer the period of time that you're storing that fuel for, will obviously have a detrimental effect on the TSP, on the sediment within that fuel. So it's trying to get that balance, and by having obviously knowledge of the pour point, the wax appearance temperature, the wax disappearance temperature, viscosity, and the TSP, you can make a much more informed sort of decision in terms of how you monitor the storage and the transfer of the fuel. So I hope that answers the questions.
Thanks, Steve. Steve, will you take this question on wax appearance temperature and wax disappearance temperature? There are two related questions. One is continues to be from Mr. Sanat Mahapatra of JESCO in Mumbai, and the other is Vijay Chalvam Silvaraju. So the question is, WAT and WDT, is it a ISO 8217 test? Will it cover under bunker claims? And the related question is, how can it be determined? Can BPS advise if it is in the standard lab test?
Okay. The wax appearance temperature, wax disappearance temperature test method that we use is not an ISO 8217 method. During the course of early part of 2019, BPS recognized that obviously there would be a more paraffinic content within VLSFOs, and that in turn could obviously lead to wax precipitation, depending upon how the fuels were stored or transferred, etc. So we set about developing a test method, because effectively wax appearance temperature is in effect the cloud point of the fuel. With obviously cloud point, you're looking at a test that has been predominantly used for distillates, which are clear and bright, so you can actually see when the fuels start to become hazy as the wax starts to precipitate. However, with a dark fuel, obviously you can't physically see that. So you need to have a test method which can actually monitor and check when the wax is about to precipitate. And what we use is a near-infrared detection system to do this. And so it's a proprietary VPS method that so we developed throughout the course of 2019, fully validated in comparison, obviously, with the traditional sort of cloud point test method. And as I said, it's not part of 8217. It may be something that is considered in years to come, but at this moment in time, it actually is a VPS method. As I said, we've got a white paper there, which if you want to have, and you haven't had access to it, and you wanted to see that white paper, we can certainly provide it. What was the second part of the question? Sorry, Raul.
No, that's pretty much it's sort of linked with.
Yeah, you're asking whether it could be involved in claims.
Yes.
The test is not a commercial test in terms of the supplier providing a fuel which has a wax appearance temperature too high, too low, etc. It is purely a test that will help improve the operational activity on board the ship in terms of fuel storage and fuel transfer. So I suppose in those terms, if you think it as a way of protecting your operations and improving operational efficiency, there would be a commercial return, because you wouldn't see, obviously, potential waxing, filter blockages, etc. But in terms of actually trying to make a claim against a supplier for wax appearance or wax disappearance temperature, that's not really what its intention is, and it couldn't be really used in that context.
Okay. Thanks, Steve. I'm going to just link on a little bit to that. I think I will just add on there that the new ISO 8217 is under revision, and there is a good chance that items like waxing will be addressed, and the test method will be put in. So that's left to be seen. So I think I'm going to just use that opportunity, Steve, to ask you the question from Mr. Yoon Jung Yong. Would you recommend ISO 8217 2017 or the ISO 8217 2012 fuel quality standard?
Absolutely. I mean, VPS, we would always recommend that our clients, whenever possible, will use the latest revision of the standard, because that will definitely give you more protection. And I was privileged to watch the panel session yesterday, which actually Raul was involved with as part of SIBCON. And Raul, you highlighted, at this time, 30% of the samples that VPS receive are still being tested to the 2005 version of the standard, which is considerably out of date. You're talking about 15 years out of, since that standard first came into being. So 30% of samples are being tested to 2005. 60% are being tested to the 2010-12, again highlighted by Captain Raul. And only 10% of the samples we receive are currently being tested to 2017. Yet that standard will give you actually the most protection in terms of modern day fuels. The standard evolves as fuels evolve over the years. So we would definitely recommend that wherever possible, clients use the 2017 standard, and that will give them most protection. There are things like, obviously, parts of the standard which we refer to the bio presence within distillates, biodistillate grades, which are actually within the standard. So, the standard is moving with the times. It may be slightly behind at this moment, but the new revision is obviously underway. And but yeah, I think the short answer is where you can, use 2017.
Thanks, Steve. Paul, I think I'm going to pose the last question to you. I'm afraid we do not have time for all the questions. This is a question from Gabian Chu, who was the very astute journalist from Manifold Times. So let's give him some ears. His question is on liner wear and engine damage. What he's saying is, when base numbers reduce, detergency reduces and the oil film is lost. When base number increases, detergency improves and the oil film is retained, but deposit formation starts. It seems whatever action is done is wrong. What is VPS advice in this case?
I'm muted.
You are muted. You're muted, Paul.
Sorry, there'll be some people that will be clapping to say, well done, we've muted Paul. Anyway, I wouldn't say that whatever you do is wrong here. I think it's about just getting the balance, isn't it? It's almost like it's getting the Goldilocks option, isn't it? It's getting what's just right. So an excess of anything it would create this imbalance in this equilibrium that we have. And if you remember, before 2020, we were happy with regards to base number and sulfur content. So we can achieve the solution that we want, but it's about ensuring that we are aware of the environment. And if we're using a certain kind of fuel, what's the correct cylinder oil that we should use? And the only way you can do that, and I would say this, but the only way you can do that is by monitoring on a regular basis. And then when you're satisfied, because there won't be any deposits being created, that means that all of the equipment on board the vessel, is operating in a satisfactory way. So it's just a matter of finding that balance.
Thank you, Paul.
Okay.
I think we have come to the end of the session. So I want to take the opportunity to thank all the participants and all the good questions that have come your way. My apologies if we have not been able to answer all of them. We'll try our best to get back to you separately. I want to take the opportunity to thank Steve and Paul for their excellent presentations, and also thank Jennifer Lowe, who's a customer service manager in Singapore, and who will continue to assist all of you in any queries you may have. You can't actually see her right now, but she's very much there in the background planning this roundtable. And finally, I would like to thank the Informa team and SIBCON for giving us this opportunity to showcase VPS. Thank you all.